In this lesson, we learn about code structure in Arduino, and we will explain the two important elements, which is setup and loop when you open Arduino and see it. We learn about breadboard and how to use it. Arduino UNO board is explained. We learn what LED is. We learn what a resistor is. Then we look at a built-in LED project, and then we run LED blink with wiring. Welcome to Arduino course by Robojax. This course is based on SunFounder 3-in-1 Arduino kit sold on Amazon. Everything that you learn in this course is included in this kit. The course comes with tons of components and projects, all with instruction and video for smart car and other projects that you can use for school or home automation. You can purchase it from sunfounder.com. The kit also comes with full documentation, code download, learning projects with full explanation, wiring diagram, and the code that you can download. The link to purchase the kit and documentation is below the video in the description. Let's get started with this. Let's talk about code structure. When you click File, New, or press Ctrl N, this page will open. Every Arduino code will have these elements. So this portion or comment. Let's talk about this. The code is divided initially into two sections, the setup section and loop, but you can add later on if you need it, and I'm going to show you. So the first portion is called setup, and it has open and close parentheses. This is a function. If I bring my mouse here, you see it says function and the name is setup. So this is a function, and void means it does not return anything. We will talk about return later when we talk about defining function. For now, just remember this is a setup, but the most important part is that this is the opening and that is the closing. If I click inside the code, inside the setup, you see the square bracket around the opening and closing. As you see, there is nothing. If I click all opening and closing, and this is common here, whatever you want to type or put, it will be just for your reference. It will be not part of the code, and you're free to write whichever way you want. You just need to put 2// and after that put your code or text or whatever you want to write, your note. Let's close this. So actually the setup is like this. It has opening and closing, but because we want to write so much stuff, we just press enter and put our code in here. Whatever we want to put must be between these two portions, so we say our code is inside setup. Now the same way loop. If I delete this, loop is also a function. This is loop, open, close, you do not touch it, and whatever you write will be inside this opening and closing curly braces. So your code will be here. You see this has moved here. This doesn't make any difference. It will work, no problem. Even if this is like that or if in the next line, it doesn't make any difference. The code will not get error. So this portion will run only once, and from the name it suggests this is loop. Whatever you write here, it will run continuously, meaning the code will come and execute first line, whatever you have, and then you have on the next line and the next line, and when it reaches up to this point, it goes back. Unless you do something here to stop it, which we are going to learn later on. So loop run continuously. This will run only once. When Arduino starts, it will run. Let me explain the board. You will connect your USB via here to your computer, and then this is external power. Once you uploaded the code from computer to the chip, then you can disconnect it and power it up from this pin, or maybe from this VN pin, and you can use it. So here are the pins. These are the input output pins here, digital in out. All of these can be used. These are analog pins where you can read analog voltage, and these are digital in and out pin. Some of the pins that have this tilde, for example, pin 3, 5, 6, 9, 10, and 11, these are PWM or pulse width modulation pins. And this is the main chip. You can input a power adapter from 7 to 12 volts to this pin. This is for USB and serial interface connection. So when you connect your USB, it goes through this chip. Then this chip is communicating with the main microcontroller. And then we have 2 pins here for I2C, and this is a reset pin. So as simple as that. And here we have 3.3 volts pin, where you can get 3.3 volts. This pin is 5 volts. You can get 5 volts. These 2 pins are ground. This is VN pin. So you can connect external power to this point. This is exactly the same as this input pin. So you can connect it, and it goes to the regulator, and you will get back 3.3 and 5 volts. So you can connect up to 12 volts to this pin, VN pin. 2 pins here for I2C or I2C. One is called SCL, the other is SCA. We have also 2 pins here, A4 and A5, are also doing the same job. So in case if you have some device that need to be connected, you can connect one into this one and one to this one. These pins that are labeled as A0 to A5, these are for analog, where you can read the voltage from 0 to 5 volts directly connected in here. What is a resistor? This page is from Wikipedia, and resistor is a passive 2-terminal component that resists against the current. This is a 2-terminal, and it has usually 4 and sometimes 5 straps of color. It's shown with these 2 symbols. One is the European, and this is the American symbols that is displayed. We have different sizes of resistor available, from very tiny to larger. These are 1/8 watt resistors. These are 1/4 or quarter, and these are half watt. The same way, this should be 1 watt, 2 watt, and then this is 5 watts resistor. This is a battery, and this is a symbol for the resistor. The current is represented by I, the voltage of the battery is represented by V, and the resistance of resistor is represented by R. The resistance that the resistor shows, the unit is ohm. And this is the path of current that goes, and this is bottom also, there is a wire. And I, or the current, is equal to V divided by R. So you can find I using this. For example, if this is 10 volts and this is 2 ohm, 10 divided by 2, 5. There must be 5 ampere current passed through this resistor. Resistors, the smaller resistors like this, they have color code on them, and that represents the value for the resistor. Here, if we have 5 color band, the color represents numbers. It starts with dark color from black, which is 0, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, and gray 8, white 9. And the color value is exactly, the number is the same, but the meaning are different. The first band, if you see it, is the first digit, second is second digit. If we look at this color, this is brown. Brown means 1, red means 0, so we will write 1 and then 0. This red means 2. So 1, 0, 2, 102, and then green is multiplier. That means 102, 100 kilo. So 102 times 100, it means 100 mega. So this means times 100 kilo. Whatever we have, we will call it 100 and 200 kilo, so 102 mega ohm resistor. And if we look at this one, this is blue. Blue is 6, green is the second band, 5, as you can see, 6, 5, and this is red. Red means 2, so 652. And then here this black is multiplier. Black means 1, so 652 times 1 is 652 ohm. And here at the end we have this color gold. So the last one is gold. Gold means plus minus 5%. So we will have 5% high or 5% low. For example, this one, the 3-band brown, black, orange. This brown, if you come here and you see brown is 1, so you will write 1, and black is 0, you put a 0. Orange here is 3, you put 3 zeros, or 10 to the power 3, so that is 10,000 or 10 kilo ohm, 10,000 ohm or 10 kilo ohm. The last band, usually you will get it either as gold or silver, but these two colors also are possible. And if these two colors are here, then there will be some extra space, so you know this color is not starting from that side. So the 3 color will be together and there will be some space, so you will start from this one. But if there is no space and this is silver or gold, you automatically know that you have to read it from this side. And this is the tolerance, either 5% or 10%. This means plus minus 5% in each 100 ohms. It goes 5 up or 5 down. This is a 220 ohm resistor. Now we have red, and then black, 2, 2, 0, because red means 2, red means 2, 2, 2, and then 0, and then black. That black means multiplier of 1. So 220 times 1 is 220, and then this is brown. If it is brown, then this is 1%, which means it has 1% tolerance. Let's use this K-Weeds multimeter. This is excellent multimeter. I have done the review. The link for this multimeter, if you want to purchase or watch the video, is below this video in the description. So even automatically it will recognize that this is a resistor and it will show you the value. Here, as you can see, it shows 220 ohm, and I can press hold, this hold button. So it is holding it for us, and as you can see, because this is 1%, it was very accurate. Let me check this resistor. I'm connecting multimeter here. It shows 991.1. Let me press hold. Hold is there, 992. Because this is 1%, it's 1 kilo ohm. Now let's check 1% of 1 kilo ohm. So 1% is 10 ohm. So this could be 10 ohm high or 10 ohm low. This is when you see something like yellowish or beige, this is carbon film, usually 5, 10, and 20% tolerance, and this is metal film, usually 1% or lower tolerance resistors. These are the two huge resistors. This is 100 watts, 0.2 ohm, J. J means 5%. And here, this is 50 watts, 2R, that means 2 ohm, J, 5%. This is 50 watts. And this has wire wounded inside. There is wire winding, and there is a heat sink to cool it down, because 100 watt is a lot of energy. In some resistors, you will see the number written on them like this, R47. This R means a decimal point and just ohm value. So on the left there is nothing, so that is 0.47, so 0.47. And here R acts as a decimal point, 4.7 ohm and 470 ohm. And if you see K, K acts also as a kilo and a decimal point. So this means 4.7 kilo, 47 kilo, and here M means mega, 4.7 mega. If you see letters, these letters, A means 0.05, plus minus 0.05, B means 0.1%, and so forth. And if you see J means plus minus 5%. Now let's have a look at some resistors under the magnifier. This says 1, 2, 4. The first one is 1, 2 is a 2, 4 means 40. So this is 120 kilo ohm. And this one is 103, which means 10,000 ohm or 10 kilo ohm. As you can see, this is 6,200 because the last 2 means 2 zeros. This means 1 kilo ohm, 1,000. This means 10 kilo ohm or 10,000. This means 62 kilo ohm. This means 4,700. An LED has 2 pins, anode and cathode. The cathode has this line, will be identified by this line, and this is the anode. The arrow always points toward cathode. In some diagrams you will see this double arrow, in some of them they just put LED, but this is the LED is connected to positive and cathode is connected to the negative. What it means is that the 2 pin will have around 2 volts difference of potential, or they will have 2 volts in order to turn this on. Actual physical LED, that the longer pin is the anode and the shorter pin is the cathode. So you will connect always the positive to this long pin. It can be either small, this is 5 millimeter, and this is a 2 millimeter. In 2 millimeter also, the long one is the positive, this is the anode, and the other one is the cathode. You can get different colors, something like yellow, blue, clear color, which is just bright white, and many other colors. We also have LEDs in here. This is surface mount LEDs, which are very tiny, but they can be also in different colors. As you can see, this is green, and this is yellow or orange, and there are red, blue, other colors available. And here LED is shown with a triangle pointing to a line, and one pin is called anode, the positive, and the side that has line is called cathode or negative. We also have some arrow or maybe 2 arrows by one of the sides, so we know this is emitting light. And for actual LED, one pin is short and one pin is longer. The longer pin is positive or anode, and the shorter pin is cathode. Now this LED, for example, if you want to connect an LED to a higher voltage, usually LEDs will need around 2 volts. In this case, if we, for example, connect it to 5 volts, then we need to have a resistor to absorb or divide the 3 volts. So from 5, it will act as a divider, and 2 will be on the LED. But we can also put a resistor like that. The only important thing is it should be on the path. Doesn't matter here or there, in cathode or anode. Still, this will divide the voltage and it will have 3 volts, and 2 volts will be on the LED, and the LED will turn on if we connect it like this. Now let's see how we do the calculation. We have 5 volts power supply, and we want to turn on an LED. LED has the voltage of 2 volts, and for this LED to be turned on, we need 15 milliampere or 0.015 ampere current must pass through this. Because this is a series circuit, the current that passes through this LED will also pass through this resistor. Now, to calculate the value for this resistor, because we know we have 5 volts power supply and 2 volts will be provided for LED, so 3 volts will remain here for the resistor. Using Ohm's law, R is equal V over I. V is voltage, this 3 volts. I is the current that passes through this. So 3 divided by this value that we have, 0.015 or 15 milliampere, is 200 ohm. And we can use a resistor 200 ohm or higher. The higher the resistor, the lower the intensity of light, and it will not harm. Only the LED will be dim. Now, because we have 200 ohm in calculation, the closest one that we have in hand is 220 ohm, and it will work perfectly fine. Now let's have a look at this LED. This is called built-in LED with resistor already there. You don't need any wiring, and it is connected to pin 13, this pin. So whatever you do, if you send signal high to pin 13, this LED will be turned on because it's connected. If you send low, it will be turned off. The same way, if you bring signal from outside, high signal, it will be turned on, and if you bring low signal, it will be turned off. Now we are going to work with this and control it easily, and then we go for actual wiring on breadboard. So this is our Arduino IDE. I'm clicking on File, Example, Basic, and then Blink. Click. And this is our code called Blink, provided with Arduino IDE. You don't need to download anything. So this is a multi-line comment. Before I showed you that this is a comment when you have double forward slash, but this is multi-line. So forward slash with asterisk is beginning of a comment, and then whatever you want to type it, and asterisk and forward slash is ending it. So this way we can end a comment. Now, as I explained earlier, this is a setup, this is loop. Setup will run only once, and loop will run continuously until you stop it or you do something. So inside the setup is a function. It has open and curly parentheses. We have one line of code. This line is comment. It doesn't do anything. You can delete it. It doesn't affect your project. So we have pin mode and then LED built in, comma, output. So using pin mode, we can control a pin to be output or input. LED built-in is a function, built-in function from Arduino. If I bring mouse over, you see it has this code, define LED built-in 13. So this is defining LED, the number 13, or this is as if I type 13, exactly the same. So this code, it means set the mode of the pin 13 as output, or set pin 13 as output. So this is defining pin 13 as an output. And LED built-in is because it's 13, so it means this pin should be output. So this is pin 13, set the pin 13 output, and this code runs only once. And when the program execution reaches to the loop, then we have this line. It says digital write. This is writing a digital signal, which means either high or low. We say it has two parameters, right, like before. This is called a parameter. We have a comma separating them. So here as well, pin 13, this is as if I type 13 and then high. So this is sending high signal or 5 volts to pin 13. And after that, now the pin 13 is high, we can connect it to LED. The LED will be high. We say keep it high for 1000 milliseconds. So this delay 1000, it means wait or delay the execution by 1000 milliseconds. And 1000 milliseconds is 1 second. After this, we are sending low signal to pin 13 using digital write, exact code, except this time we have low here. So this is turning off the LED because low signal is connected to this pin, and we keep it waiting for 1 second with a delay of 1000 milliseconds. And because we reach with execution, when the code reaches here, this is the end, it comes back to the beginning of the loop, and again high, wait for 1 second, low, wait for 1 second, and so forth. It will run continuously. Now the code is already similar to that, but we have some explanation to do. Let's upload the code. Because we have not changed it, if you want to verify, just click verify and you will see the status here, whatever happens if there is an error. So done, there is no error, compile done. We can select our board from this arrow. You will see the COM port here. It's already select it and then upload, you will see this. It compiles it again, uploading, done. Now you see this is blinking. I will turn off the light so you can see it better. Now we can control this timing here. If I set this to 500 and then 500, now you will see this blink will speed up. I clicked and sending. As soon as you see these blinks, it means code is uploaded and now it's running fast. We can do also 300 and 300, for example. Now uploading it again. Look at the blinks, TX or X. So now this is blinking faster. We can do 1500 and then 300, so that's 1.5 seconds. And if I set this to 5 seconds, 500 milliseconds, half a second. Now code is uploading. Just look at the blinks. Now this is 1.5 seconds on, half second off. Very long time on and very short period for off. The first project that we run is Hello LED, where we will connect an LED via a 220 ohm resistor to pin 9. The cathode of the LED is connected to the ground. For this project we need your breadboard, 220 ohm resistor, an LED, doesn't matter which color you prefer, one black wire and one blue wire, so when I mention the color you follow along with the same color. Anode is connected to a resistor, the other side of resistor is connected to pin 9. Here on the breadboard we can see that LED is connected, the long pin is connected to this line, where via a 220 ohm resistor is connected to this point, and from here we have a wire to pin 9. The negative pin or ground pin is connected via another wire to ground, and when we upload this code or the same code that you see, the LED will blink. Now let's do the wiring. This is an LED. As you can see, this pin is long. I'm going to insert it. Anywhere on the breadboard, somewhere in the middle. From one of the pin, from the right pin, I'm going to connect this resistor. This is a 220 ohm resistor, and connect it to exactly the way it's shown. So exactly the way it's shown in diagram. I'm connecting a blue wire from this side of resistor on the same line to pin 9, and from the other pin of LED where there is no wire, I'm connecting it to ground. So now the wiring is done exactly as it is shown in the diagram, and I'm going to connect the power. Let's go and click on File, Open, go to where you have saved it. I've saved it under Download, SunFounder 3-in-1 kit, Learning Project 1.1, Hello LED, and click Open. The code is exactly the same as the built-in LED, but here we are learning something new. We are defining a variable of our own. Here we say LED pin of type integer, and then we define the value of 9, and because to prevent it from changing in the code, we could use it like this, but we have put here which means constant. It means it's not changeable. So this cannot be changed throughout the code. And here we say 9 is assigned to this variable called LED pen. Now, instead of 9, we are using LED pen everywhere. So this means this is as if I type here 9. And through this is exactly the same as the code that I've explained. And now let me upload it. First, let's verify it if there is no error. Done, and then upload. We know that if this blinks, we know the code has been uploaded, and this LED will start blinking. And as you can see, the LED starts blinking. And the same as before, we can put 1,500 and then 500. Let's just upload it. Now code is uploaded, 1.5 second high and then half second low. Congratulations, this was your first project and well done.